So for question number 1 from this homework, we're going to look at finding the determinant. Remember, the determinant for a 2 by 2 matrix takes a diagonal -4 times 5 minus, and then we do the other diagonal, which would be -3 times 6. Put lots of parentheses there. So this is going to be -20 and minus -18, which turns into -20 plus 18. So we get -2 is our determinant. Remember, the determinant, the notation we use is these vertical bars. For number 2, when we're looking at a 3 by 3 determinant, there's, again, 2 ways that you could do that. So I'm going to go over both ways. You could choose whichever way that you like. So the first way, if we're going to do by minors, you want to pick a row to do that with. And it could be any row or column. I normally try and pick something that has the zeros in it. So again, the first way is with the minors. If you like this way, then follow along. If not, the second way we're going to do it is with the diagonals. So if you like that one better, then you should scroll ahead. Okay, so with the minors, I'm going to actually choose just the first column. So remember the way that works, we write those entries. And then the signs, because this is like A11, that's even. This is A21, that's odd. And this is A31, which is even. We're going to keep the same. So we write that like plus sign. Opposite, so we negate that. And then same, it's going to be keep it the same, so that plus sign. So the only thing that we have to change, this is staying the same. This is going to be opposite. That stays the same, but it doesn't really do much. Then we're going to multiply those by the corresponding minor. So I'm drawing these lines here to indicate I'm going to find a determinant. So when I take the first entry 4 and I cross off the column and the row, I'm left with -1, 2, 8, and 0. Whoa, I don't know why that jumped. All right, and then when I look at the 0, I'm going to cross off again that column and the row. So the entries I have left are 1, 3, 8, and 0. And then for the last one, for the 5, crossing off the column and the row, we're left with 1, 3, -1, and 2. So we need to find those little determinants. So -1 times 0 is just 0. Minus, we got to do 2 times 8, which is 16. And then we'll multiply that by 4. That's the first one. So it's really going to be 4 times -16. For the next one, we're looking at 0 times that determinant. So really, that's just going to be 0, so we don't have to do any work there. And then the next one, we're going to take 5 times, again, 1 times 2 is 2. 3 times -1 is -3, so we're going to minus that -3. Because remember, the determinant is the first way minus going the other way. So this is going to be 5 times 2 plus 3 is 5. So we're going to get -64 plus 25, which if you take -64 plus 25, we get -39. So -39 is our determinant for this 3 by 3 matrix. Now we're going to use diagonals, and we should get the same exact answer. So to use diagonals, remember, we're going to look at the 4, 1, 3, 0, -1, 2, so the regular matrix that we have. But then we're going to add on another 2 columns. So we're going to repeat the first 2 columns. And what this is going to allow us to do is to look at the diagonals. So we're going to look at I'm going to start with the upper corner. We're going to look at those diagonals this way. And so that's going to be 4 times -1 times 0 plus 1 times 2 times 5 plus 3 times 0 times 8. So that's going in that forward direction. So we're going to find out that whole quantity. Then we're going to minus, let's go the other way. So these diagonals going this way. We're subtracting those off. But individually, let's just multiply 1 times 0 times 0 plus 4 times 2 times 8 plus 3 times -1 times 5. And so we need to figure out those 2 quantities. So the first top quantity is going to be, well, that's a 0 and that's a 0. So we're just going to get a 10. And then on the bottom part, let's see, this is going to be 0. This one right here, though, that's going to be 64. And then we have this together is going to be negative 15. So this whole entire quantity here, we're looking at 0 plus 64 minus 15. So 64 minus 15 is going to be 49. So what we're looking at again is going to be, this is 10 minus that 49, which will equal negative 39. And again, these have to match. We did it the two different methods, we should get the same answer. And that even means, just a reminder, that if on the first one, if you choose not to do the minors along the first, you can use another column or row, and that would be fine too. Okay, we're going to move to number 3. Now it wants us to solve using Cramers rule. So Cramers rule is basically you're finding a few determinants. So this is a 2 by 2 system, so we have to find our x value and our y value. So we're going to look at finding the determinant where we replace the x column with the constants. And then we're going to look at finding the y value where we find the determinant by replacing the y column with the constants. So let's see what those matrices or those determinants look like. So first, the big D, that's looking at the coefficients of my x and my y. So I'm going to write determinant, so that's my vertical line, negative 4, negative 3, 6, and 5. And so we're going to do that diagonal multiplication. So negative 4 times the 5 minus, because that's just what determinant says, we'll go the other way, negative 3 times the 6. So this is going to be equal to negative 20 minus negative 18, which is negative 20 plus 18. We get negative 2. So this is our big D. So then for our next part, dx, remember we're going to replace the x column. So if you look back at our previous determinant, those were the coefficients of our x's. These were the coefficients of our y's. And then over here are the constants. So to find dx, we replace the x column with negative 4, 8, but then the other part stays the same. And again, we're going to find the determinant by doing the cross multiply. So negative 4 times 5, again, minus, because that's what our formula does. And we'll have negative 3 times 8. So this is going to be equal to negative 20 minus negative 24, which is negative 20 plus 24, which is 4. So this is our dx, our determinant, where we replace the x column. So then our last guy we need is dy, which is going to be equal to, we're going to replace now the y column with that negative 4, 8. So then our x column is what we had originally, negative 4, 6. And again, cross multiplying here, negative 4 times the 8. We're going to say minus, and we'll go the other way, which will be negative 4 times the 6. So we're going to end up with negative 32 minus negative 24, which is negative 32 plus 24, which is negative 8. And that's our dy. So then we're going to take these three and replace them to actually find our x and y value that satisfy the system. So to find the x, we're going to write the 4 over negative 2, so we get negative 2. That's our x. For the y, we get dy, which is negative 8, over that negative 2, which is 4. So then we have the solution to our system will be an x value of negative 2, y value of 4. This is the solution. If I want to check, just plug these in to our original system and make sure it satisfies both of them. All right, number 4, we're going to do the same thing again. So we need to find our d, dx, and our dy. So let's start by finding our d, which will be, again, looking at the coefficients. So we'll have negative 5, 4, coefficients of x, coefficients of y. And for our determinant, we're going to take negative 5 times the 7 minus, and going the other way, negative 8 times the 4. So this will be negative 35 minus negative 32, which is negative 35 plus 32, which is equal to negative 3. So that's our big D. Then we need to find our dx, which again, that's going to replace the x column with those constants, 3 and 13. The y values stay the same as our last determinant. So then we're going to cross multiply. We'll do 3 times the 7. And then we're going to do minus, because that's what the determinant says, negative 8 times 13. So we're going to get 21 minus 8 times 13. That's going to be 80 and 24, 104. So we're going to have negative 104. So we have 21 plus 104, which will equal 125. That's going to be our dx. All right, and then last we need to find our dy, and we're going to replace now the y column with that 3 and 13. And so the x column is still the original, negative 5 and 4. So we're going to do our cross multiply, negative 5 times 13 minus, we'll cross multiply the other way, 3 times 4. So we're going to end up with negative 65 minus 12, which is negative 77. And that's going to be our dy. Some bigger numbers this time. That's okay. So then if we go back, our x value is the dx over d. So that will be 125 over negative 3. And our y value will be dy over d, which will be negative 77 over negative 3, but that's going to be positive 77 over 3. So the answer to my system here, my x value is negative 125 over 3 and 77 over 3. So what's really nice about Cramer's rule is when you're solving a system where you do get fraction answers, there's nothing wrong with getting fraction answers. We saw no fractions in the actual solving part. It was so if we want to double check that we're right, you can plug it back into the original, and maybe this might be nice to check because you don't expect fractions. Well, a lot of students don't expect fractions anyway. So to check it, again, we're going to plug into our original system. So the first equation is going to be negative 5, plugging in the negative 125 over 3. And we have that minus 8 times the 77 over 3. This is supposed to equal 3, we hope. So the first part, let's see. So it's just double checking on this. If I multiply the negative 5 over 1 times negative 125 over 3, that's going to be 625 over 3. And then the 8 over 1 times 77 over 3, that will be 616 over 3, which is going to be equal to 9 over 3, which does indeed equal 3. So I checked it on that one. So you should check it in the other one too, just to verify, because it's supposed to satisfy both equations. So make sure you check on that one too. Okay, for number 5, we're going to find just z using Cramer's rule. So the reason for that is because we could find x, y, and z with Cramer's rule, but we're going to save a little time because really they're all the same. You need to find determinants. So by just asking you to find z, you only need to find 2 different determinants. So first, the determinant of the coefficients is going to be 2, negative 5, 1, 3, 7, negative 4, 1, negative 9, 2. So I need to find the determinant of that. I'm going to just do the diagonals this time. If you like doing minors, go ahead and do minors. We should get the same answer either way. So I'm going to, again, add on the first 2 columns. So we'll get negative 5, 7, negative 9. And then we're going to do the diagonals. So going in the forward direction, we're going to have these 3 diagonals. So that will be 2 times 7 times 2 plus negative 5 times negative 4 times 1 plus 1 times 3 times negative 9. So that's the forward direction. Then we're going to minus, and let's go the backwards direction. So we're going to do this diagonal. There has to be 3 in a row. So that's why we added on those 2 columns. So we're going to have 5 times 3 times 2, oops, that was negative 5, plus, we'll do 2 times negative 4 times negative 9, plus 1 times 7 times 1. And so the first quantity up here, when we multiply and then add those guys together, let's see. This is going to be a 28, and then we're going to get a positive 20, and then a negative 27. So that's going to add together to be, let's see, 21. And then looking at the next part down below here, that's going to be negative 30, and then we're going to get positive 72, and then positive 7. So when we combine that together, that's going to get us about 49. So what we're looking at here is really 21 minus the other diagonals, which added up to 49. So this is going to be equal to, let's see, negative 28. So we have our big D is negative 28. So we also need to find dz. So remember, that looks exactly like the D determinant, except the Z column is replaced with our constants. So that was 11, 8, and 4. Right here, the 11, 8, and 4. And so the other two columns are going to stay the same. So 2, 3, 1, negative 5, 7, negative 9. And then I'm going to rewrite those first two columns off to the side here, so that way I can do the diagonals again. So again, for the diagonals, I'm going to find my 3 in a row, and I'm going to multiply each of those diagonals and then add them up. So that'll be 2 times 7 times 4, plus, we'll do negative 5 times 8 times 1, plus 11 times 3 times negative 9. So we're going to have to find that. Then we're going to minus, and let's do the diagonals the other way. Again, 3 in a row. So I have negative 5 times 3 times 4, plus 2 times 8 times negative 9, plus 11 times 7 times 1. So the first chunk, the forward facing, is going to be, let's see, we're going to multiply and add all that together. It looks like my total will be negative 281. So make sure you double check on that. Use my calculator. And then on the bottom here, that's going to be negative 127. So what we're looking at is negative 281, and again, minus the other diagonals, which added to negative 127. So really that's negative 281 plus 127, which will equal negative 154. So we know that dz is negative 154. So going back to the top, our dz over d, well, that's going to be negative 154 over negative 28. We could get rid of the negative because it's a negative by negative, so it'll be a positive 154 over 28. And we can reduce that. The top and bottom both can divide by 2, and well, actually by 14. So if we divide by 14, 154 divided by 14 gets us 11, and 28 divided by 14 makes us get 2. So we get 11 over 2 for our z. Okay, we're going to look at number 6. If you notice, 6, 7, and 8 are all the same exact system, but they're using different methods. So we're going to skip number 7 for now. And we're going to look at just 6 and 8, but again, because they're the same systems, they should have the same solution. So it's really just asking us to use two different procedures. So we're going to first use Gauss or Gauss-Jordan elimination, then we're going to do it by Cramers rule. Okay, so first, using Gaussian or Gauss-Jordan elimination, that means we want to use the matrices to try and get our system looking either with the diagonal of 1s and the 0, or the diagonal of 1s and the 0 and then another 0. And that way we can just see our solution. So again, either Gaussian, or you can keep going and do the Gauss-Jordan elimination. So let's see, the first thing we need to do is put this in order. So the first equation should be x. If I add the 3y over, That's x plus 3y equals negative 10. And we have negative 3x minus 7y equals 22. So this augmented matrix for the system would be 1, 3, negative 7, negative 10, and positive 22. So there's our augmented matrix. And so, yay, we already have our first part of our goal, which is the 1. So now we need to turn this into a 0. And so if we want to make a negative 3 go away, we're going to have to have a positive 3 to add to it. So again, one of the purposes of making the 1 happen first is so we can multiply by it. So I need a positive 3, so positive 3 times that 1, which is in row 1. If I add that to row 2, that can make my new row 2. So the only matrix I'm really changing is row 2. I'm going to write my scratch work so you can see that. But again, you could just do that in your head if you want. So 3 times row 1 will be 3, 9, negative 30. Row 2 is negative 3, negative 7, 22. So when I add those together, my row 2 will be 0, 2, and negative 8. So my matrix, row 1 is staying the same, 1, 3, negative 10. But row 2, we just found that, will be 0, 2, negative 8. So now I have the first part of my goal, which is to have the column of 1 and 0. So the next, I'm going to try and make the 2 turn into a 1. So normally to make zeros, we use the row operation where you multiply a row by something and then add that to your row. That's how we make zeros. If we want to make ones, there's a couple different ways you can make that happen, but one of the most common is just to divide by whatever that number is. So if I want 2 to turn into a 1, I need to divide by 2, which that is a row operation. We don't really say division, but it's taking the row 2 and multiplying by 1/2. If you write R2 over 2, that's still the same thing, so it's fine, but that's what you're doing now to change row 2. So again, either one of those is okay. So my matrix, my first row did not change, only row 2 again. So row 1 stays at 1, 3, negative 10. Row 2, if I divide by 2, will be a 0, 1, negative 4. So I could stop right now and do back substitution. I already know that y equals negative 4, so I can back substitute that. And that means I have done Gaussian elimination. But I'm going to keep going. I'm going to turn now this 3 into a 0. So remember, if I want to make a 0, I'm going to take a multiple of the other row and add. So 3 needs a negative 3 to go away, so I'm going to take negative 3 times row 2. That's using the 1 I just made. I'm going to add that to row 1 to make my new row 1. So my little scratch work for that, negative 3 times row 2 would be 0, negative 3, and then 12. Adding that to row 1 is 1, 3, negative 10. Which makes my new row 1, 1, 0, and 2. So my matrix has row 1 now being the 1, 0, and the 2. And my second row is staying the same, 0, 1, negative 4. Now I have done Gauss-Jordan elimination. This is in reduced row echelon form. So the first row is x plus 0 equals 2, so I get x equals 2. Second row is 0 plus y equals negative 4, so I have my x and y. 2, negative 4 is the solution. If I want to check that I'm right, I could just plug it back into my original system, and I will see that it does work, so you should check that. We're also going to use another method in the next problem, and we should get the same exact answer. So let's look at question number 8. Again, we're using the system. I'm going to move that top row over. It's the same system that we already had. So we're talking about using Cramers rule. We need to find out our dx, our d, our dy, and then the d again. That means we need to use determinants. So our d uses the coefficients of our x and y, so 1, 3, negative 7. And we're going to cross multiply 1 times negative 7 minus, because that's our deal with determinants, 3 times negative 3. This will be equal to negative 7. This is negative 9, so it'll turn to plus 9. So we get 2 for our big D. Then we're going to need to find dx. So remember, dx makes us replace that first column with our constant. So it'll be negative 10, 2. The other part stays the same. And again, we're going to find the determinant. Negative 10 times negative 7 minus, because that's our formula for that determinant, the diagonal the other way, 3 times 2. So this is going to be equal to 70 minus, oops, what did I just miss? That was a 22. Let me step back for a second. This was supposed to be a 22, so that should be a 22. And just kind of double checking, that should have been 22. So 70 minus, that's 66. So be careful there, which gets me a 4. That's my dx. Then I need to find my dy, which is replacing not the first column, that stays the same, but replacing the second column with that negative 10 and 22. Be careful with that. And so then this is going to equal, we cross multiply, 1 times 22 minus, because that's the formula for determinant, negative 10, the other diagonal, negative 10 times negative 3. So this is 22 minus positive 30, which will equal negative 8. That's our big dy. So now putting this together, going back up to where we were, our x will be a 4, that's our dx, over 2, which is 2. And our dy is negative 8 over our d, which is 2. We get negative 4. So we're getting 2, negative 4, which again is the same answer that we got over there. And with both of these, we could also use our previous solving by elimination and substitution to solve. And we get the same answer, 2, negative 4. We could even do graphing. If you graph both those equations, again, their intersection point will be 2, negative 4.